Okay, so we did a flat mirror a minute ago. This was the front of the mirror. This was the back. Virtual, image, upright, same size. The lines kind of show that it's virtual. The rays are coming from this side and bouncing back, right? Okay, so now what we're going to do is we're going to start looking at curved mirrors, okay? Curved mirrors are a little different, but follow the same principles, okay? We're going to look at first a concave mirror, okay? Concave, if you know the Spanish word con, that in English means with, right? And then cave, you think of an indention, right? You think of an indention into a rock. And so a concave mirror is going to be with indention, okay? And it's basically a segment of a sphere, okay? So if you were to look at it, then this is just a big bowl shape. It's like a spoon, except really more spherical, whereas this is going to be, I don't know, more parabolic or something. But it's, for a concave mirror, it's really more spherical, okay, at least with the diagrams we're going to be doing. Now, they actually use more parabolic shape whenever they do most mirrors because of something called spherical aberration, and we'll get to that a little later. Basically, it means the lines don't focus where they're supposed to as well. If you used a parabola, they focus better. Okay, so this is the concave, or the with indention part of the spoon. This is the convex, and that's the next mirror we're going to do after this one. So the back is convex, the inside concave. Okay? Alright, so again, that means with indention. Okay, I think that's the right way of spelling it. Now, kind of interesting thing about this is, again, like I said, it's a sphere, right? It's a spherical mirror. So if we were to say the radius of the sphere is, and I kind of have this scaled out about 5 inches there, but we'll say the radius of the sphere is out here at about 4 inches from here. So 5 minus 1, 4 inches, right? We call that the center point of the mirror, okay? Center basically gives you the radius from that point. So if it was a big giant ball, this would be the absolute center point of the big giant ball, okay, the big sphere. Now halfway between center point and the mirror, you have another location. That's called the focal point, okay? We'll go ahead and use black for that as well. That focal point, again, is halfway, so that would be 2 inches, while the center point was 4 inches. Okay, I'll just get rid of that so it's not confusing. Alright, so here's what happens. If we have an object that's sitting in here, in our mirror here, and it's sitting out here, we'll say maybe this object is about a ½ inch tall. So I'm just kind of guessing there on what the half mark would be between those two marks, but we'll say it's sitting about right there, okay? The way we figure out how that object appears is we use a ray diagram, okay? We begin tracing ray lines. And so the first line we draw always goes parallel to the principal axis, okay? You still hear Macy there. She said, "I want more snacks." Okay, so here's the first line we're drawing, and this line right there, I'll label it for us. It's the principal axis, okay? Alright, that may actually be AL. For right now, I'm not worried about it. But so that first line goes parallel to the principal axis until it hits the mirror, and then it bounces back, right? It goes through the focal point. That's the first line. Okay? Alright. Now the second line you draw, and I'm going to use a different color here so you can see the differences. The second line you draw goes straight through focal point. Okay? So it's going to start here, go straight through the focal, and hit the mirror. Okay? And then when it bounces back, it bounces parallel to the principal axis. So the first one starts out parallel, the second one ends up parallel. Okay? Again, that's the continuation of line 2. Here's the continuation of line 1. That's where the lines kind of bounce and intersect. Okay? Alright. Now, the last line, you can draw a third line. Okay? And my mirror, for the third line to work, and for you to really see what's happening, I'm going to extend my mirror down here so that you can see this. What happens is the third line goes straight through center and straight back up. Okay? Straight through the center point and right back up. Okay? And it's close. I mean, my diagram's not perfect, but it works. And the general idea is what you want here. Now, where those lines intersect, okay, right here, those lines are intersecting. That is where this object is going to appear. And so what you do is you start with wherever you started the line. We start at the tip of the arrow, and that's where you want to start. It's like the top. Okay? When it comes, hits, that tip of the arrow is going to be right there then. Okay? Hits and bounces back. It's focusing right there. So we put the tip of the arrow right there where those lines intersect. And then the bottom of it is going to be right there on the principal axis. Okay? When you do the virtual lab on mirrors and lenses and everything, this is kind of what you're dealing with, is you are dealing with the same principal axis and you've got the rays lining up. Now, I think on the lab it's all lenses. For a mirror though, this is what it looks like. The lens is very similar though, except it passes through and focuses on this other side. Okay? Now, here's when the math comes in. Okay? What happens is we have the equation of 1 over the object plus 1 over the image equals 1 over the focal length. Okay? And so if I were to measure our object distance here, okay, start at 0, that looks like about 4.5 inches to me, okay, maybe 4 3/4. So yeah, let's say 4 3/4, okay. So if P is equal to 4.75 inches, okay, and we know what F is, because F we said was 2 inches, then we should be able to solve for Q and see if it matches what we got here, okay? Alright, so I'm going to move down here to this side of the page so I'll have a little bit of room. So if I said 1 over 4.75 equals, or pardon me, plus 1 over Q is equal to 1 over 2, then I can begin to isolate, right? And say 1 over Q equals 1 over 2 minus 1 over 4.75. Okay? Alright. Once I do that, and I don't have my calculator with me at the moment, and just because of time I don't want to worry about that, I can go ahead and put these in decimals. 1 divided by 4.75 is going to be a little bit less than 0.2, right? So we'll say roughly 0.1, I don't know, about 0.185 or something like that. equals 1 over Q. And so take then and solve for the difference, right? Okay, and solve for Q. And we won't work through the isolation of that. I think you guys are great with that. We've done plenty of those, and without my calculator, I really don't want to get too far off the answer, but it gives you the idea of what to do, okay? So this is a concave mirror. I tell you what, I'm going to stop here. I'll do another diagram of a convex mirror, so that we can kind of keep these shorter and they'll be able to load on YouTube a little bit easier, okay? All right, good luck.